Hello, welcome to this video. Now, in this video, I've got a very interesting part under chemical reactions, and we're going to look at energy profiles. Now, specifically, we're going to consider two types of reactions. That is the endothermic reactions and the exothermic reactions. So, what are these energy profiles? Well, the energy profiles, also known as the energy level diagrams, they represent how each of the endothermic and exothermic reaction proceed. All right. Now, as we know, I'm going to write for endothermic here, and I'll write for exothermic this side. Exothermic. So, for endothermic, all right, what you need to know is that the enthalpy change, which is the heat of the reaction, is just the heat of the product minus the heat of the reactants. Wow. Well, it is still the same. The only thing is that for endo, it is the heat of the reaction is negative, but for the for the endo it is positive. All right, but for the exo it's actually negative. That's the one key difference that you need to know. But when it comes to drawing of the diagrams, all right, how are they different? So I'm going to draw a very simple diagram here so that you can see how I'm drawing it. Okay, so like that. And let me also draw here so that you see the difference in the way they go between the exo and the endothermic. All right, let's draw it like that. I think, yeah. So how do they go for the endo? Now, remember that for the endothermic, for you to get a positive value, it means the products, they must be at a higher energy level as the reactants. What do we mean? It means the reactants will be at the lower energy level as compared to the products. So here you have the products, and here you have the reactants. And that's all. Then what else do we have to know about this? Well, here we have energy. Can be in kilojoules or joules. Something applies to this other profile here. And here we have, in the x-axis, we have got what we call the progress of reaction. Same thing here, we have progress, okay, of reaction. All right, now, what else do we have to know? Well, where do we put delta H, the one we're calling the heat of reaction? Well, if the heat of reaction is the difference between the product and the reactants in terms of heat gained and heat lost. So that is the change in H, which is the change in heat. What about for the exothermic? Well, for you to get the negative here, it means that the reactants now are more than the products. That means you expect the reactants to be at a higher energy level as compared to the to the products. So what are we saying? It's a situation like this, then it goes like that, then you have something like that. So here we have the reactants now that are now at a higher energy level, and we have the products at a lower energy level. And this is corresponding to the fact that under exothermic reactions, the enthalpy of change is actually 0. So now, where is the delta H? Okay, well, it is still this difference here in energy between the reactants and the products. Well, under exothermic, you are going to get a negative, and under endothermic, you are going to get what? The positive. Because under endothermic, there is what we call bond breaking, but under exothermic, there's what we call bond formation. So these are the energy profiles. I forgot one thing, which we are calling the activation energy, which is the energy given to the reactants in order to initiate a chemical reaction. So that energy is usually given to the reactants themselves. So in this case, that will be given somewhere there. Okay, that would be the activation energy. While here, it will be the energy given to the to the reactants here. So basically, that's how this friend of ours is done.